In this video, we're going to be looking at a question that involves calculating the expectation and variance of a distribution of x from a PGF. So here's the question. I'll have you attempt it first before checking out my solution. It says x is a discrete random variable which takes the values 0, 2, 4, and so on. The probability generating function of x is given by gx of t and is equal to 1 over 3 minus 2t squared. So on A, find e of x and the variance of x. Alright, so let's work on it. Now, here we want to find the expectation to start with, and we have learned that the expectation e of x is found by g dash of 1, which means we have to differentiate the PGF g to get the expectation after substituting 1. Right, so here we're saying since g of t is from the question, I'll write it as 3 minus 2t squared all to the power of minus 1, then g dash of t will come from differentiating this, and we can use the chain rule for that, or you can use this method where you bring down minus 1, then you differentiate minus 2t squared, and we get from that minus 4t. Then we write down the 3 minus 2t squared, then we subtract 1 from the power. So this gives us 4t of 3 minus 2t squared to the power of minus 2, which is 4t, and that's over 3 minus 2t squared all squared. Now for the expectation, therefore, since we say that it's found by g dash of 1, so here that will just be 4 of 1, and that's over 3 minus 2 of 1 squared, which is basically 1 squared. So we are going to get the expectation e of x coming out as 4. So that's what we get for expectation here. Now we want to talk about the variance. And we know that for the variance, it is found by g double dash of 1 plus g dash of 1 and it's minus g dash of 1 squared. So that means we shall need to find the second derivative, that is, we shall need to find g double dash of t so that we can get g double dash of 1. So we're saying since from above we got g dash of t to be, from here we got it to be 4t of 3 minus 2t squared to the power of minus 2, like we got right here. We can now be able to find g double dash of t using the product rule. So for the product rule, that will just be 3 minus 2t squared to the minus 2 times the derivative with respect to t of 4t, and that's plus 4t times the derivative with respect to t of 3 minus 2t squared to the minus 2. So this is equal to, if we differentiate 4t with respect to t, we get 4. So we have 4 of 3 minus 2t squared to the minus 2. And here it's plus 4t, this 4t. And if we differentiate this with respect to t, we can either use the chain rule, or we can say bring down the minus 2. So minus 2 brought down. Then differentiate minus 2t squared, and that will give us minus 4t. Then we write down the 3 minus 2t squared, then we subtract 1 from minus 2, so it becomes minus 3. Alright, so we can simplify this. That's going to be 4 of 3 minus 2t squared to the minus 2. And here for 4t times minus 2 times minus 4t, we get 32t squared. And that's of 3 minus 2t squared to the minus 3. So this is what we get for g double dash of t. Alright, so here we are going to need g double dash of 1, which means we simply substitute 1 into this. If we do, we'll be having 4 of 3 minus 2 of 1 squared is like 3 minus 2, which is 1, and 1 raised to the power minus 2 will just be 1, and it's plus 32 of 1 squared of 3 minus 2 of 1 squared. So all this will simply also give us 1. So we get 36 for g double dash of 1. Alright, so therefore for the calculation of variance, which we said is g double dash of 1 plus g dash of 1 minus g dash of 1 squared, that will be equal to, here that will be 36 plus, for g dash of 1, we got that to be 4, that's the expectation, hey? So we have 4, and it's minus 4 squared. And simplifying this, we are going to get 24. So the variance is 24. So that's how we do it. So we are done with the first part of the question. Let's go on to the next part. On part B, the question says, find the probability that x is equal to 4. Alright, so here, from the question, we've been given that gx of t is equal to 1 over 3 minus 2t squared. So our goal now, since we are calculating a probability, is to express this in series form and get the coefficient of the term in t to the power 4. So this is the same as gx of t being equal to 3 minus 2t squared raised to the power of minus 1. So here for 3 minus 2t squared, I will factor out 3, which means I'll be having 1 minus 2/3 of t squared. And that's all raised to the power of minus 1. So this means that we have 3 to the power minus 1 of 1 minus 2/3 of t squared to the power of minus 1. Now applying binomial expansion, for 3 to the power minus 1, that's a third. And that's of expanding this, it will be 1 plus nx, which is minus 1 of minus 2/3 of t squared. And it's plus n of n minus 1 over 2 factorial, which is minus 1 of minus 2 over 2 factorial of minus 2/3 t squared squared. And it will continue going all the way. So we have a third of 1, and simplifying this part, we'll be getting plus 2/3 of t squared, and it's plus, here, minus 1 times minus 2 over 2 factorial will give us 1. Then minus 2/3 squared will be 4 over 9, and that's of t to the power of 4. And it continues going all the way. So basically, we have a third plus 2 over 9 of t squared plus 4 over 27 of t to the power 4, and going all the way. So therefore, for the probability that x is equal to 4, we're simply looking for the coefficient of t to the power 4, which comes out as 4 over 27. So this is the answer we get for part B.